Now that we have talked about SPIs, let's look at how safety feedback works during the life cycle. We have design, we have testing, we have deployment, and I added the safety case that's something that spans all of them. The architectures for autonomous vehicles will need to have support for field feedback across the life cycle. That's going to have to be built in for this technology to really deploy at scale safely. Today, we have a design and we do hazard analysis and we improve the design until the hazard is mitigated. And then we do testing, and the testing reveals some sort of triggering events, and we go back and we account for those in the design, and we iterate, and then we deploy. Today, when we deploy, we have some runtime safety monitors. Now, if you have a human-driven vehicle, that's the driver. If you have an automated vehicle, that's the runtime safety monitor that says something like, oh, I'm too close to the car in front of me, I'll command the control system to slow down. You still want those, but those are not SPIs. They sound kind of the same. I'll never be too close, so I'm going to slow down. But runtime safety monitors take an action in the moment, but they don't fix the problem. So if you had a runtime safety monitor activating every mile, this diagram wouldn't change that. It would activate every mile for the life of the car. What you want is something to do better. You want to not put yourself in danger in the first place by using some sort of engineering feedback. Now, currently, we do recalls. Something bad happens on the road, and there's an engineering recall. And recall is not the visit to the repair shop to get it fixed. Recall is the engineering process to notify everyone that there's a problem and to drive a fix so the fix gets deployed. So the recall is the process, not the actual fix, to be clear. And we use a recall process to go back and fix the design and test and deploy a remedy. With safety performance indicators, we're going to change how we think about that. SPIs link design issues and testing issues and deployment issues back to the safety case. And so instead of waiting for tens or hundreds of incidents or perhaps injuries or perhaps even fatalities before we realize a recall is needed, we want much stronger instrumentation to change to a continuous improvement model where in a deployment, there was a near miss. You don't wait for someone to complain. You don't wait for there to be a visit to the hospital. You say, that's not right. Our safety case said that shouldn't happen. It just happened. Let's go figure it out and fix it with high probability before we have the crash. And so SPIs will move you away from a recall model to a continuous improvement model that is likely to improve safety. Now, this does not mean you deploy unsafe and use SPIs to make it safe later. You deploy with a good faith belief that you're safe and a healthy respect for the fact that there's uncertainty around that knowledge. And the SPIs feedback data both during testing and after deployment to make sure you're really as safe as you think you are, and to also detect changes in the environment that pushed you out of safe into unsafe because something about the environment changed that you had no control over.